Hello everyone, this is Mr. Mouse and I will be looking at some files from the game AI War, which was on, as you can see here, on Good Old Games. I won't be playing the game, but I will be looking at two of the files, resources.assets and share.assets. So two files, and I can take a look at them. So at first glance I can see that in both files there seems to be some kind of table before new stuff starts. So looking also at the other file, indeed there's even some chunking I think going on, because it seems that the file starts here 1000 hexadecimal. Actually this is an OGG file, so this is a sound file. Looking at this, it seems to be starting with 9, so 9, and then start the game, which is a name probably, which is 9 in length, number of bytes. So the 9 here is obviously referring to this name size, and then something begins. Looking at the back of the file, there's nothing much going on in terms of strings like file names or whatever. Not in this file as well. This doesn't. No, it doesn't seem to be like that. Though you never know, because again there's 13 here, and then 13. So this these could be actually small files. Okay. Coming back to the above, also for this one, let's take a look at the header. This seems to be to let me see. This is 2D40cc. It's a excuse me. This is a different NES, but it's 2D40cc, and probably that will be DS, the ArchiveSize 2D40cc. So we know that now. Oops. So ArchiveSize, this is 919. It's probably somewhere relating to this size of this particular table here. I don't know, maybe it's 3. What's the 919 going backwards? Yeah, well, it doesn't make really much sense, so starting here. But anyway, it looks like it. It's not very important probably. But something like header size, and then they calculate something. 9. I have no idea what this is. This looks to be the data offset, like we saw in this file here, starting here at 10. Let's compare with the other file. So this would be again header size. I'm not looking what I'm typing, so I could be wrong. ArchiveSize 2D8FB4, is that correct? 2D8FB4, that is correct. 9 again, whatever that is, and then 1A50 as a data offset. Where does that lead us? I still have a bit of a cold, so my voice is still not very functioning very nicely. What is this? Nothing. There's no there's no number here. Okay. Could be anyway. I mean, it could still be. Doesn't need to be like that. It could be different than I expect. Excuse me. So this is no idea what this is. Now this is text actually. 4.2.1 F4. Same here. 4.2.1 yes. So this probably is like some kind of version or something. Like build version. Whatever. And then a 5 and then a 5 there. And then something and then something and then 3.7 1 9C 6E 6E 9C 50502. Okay, so now the endianness is reversed again. If that's starting from 1, let's see if this is a table entry. It ends somewhere around here, I would guess. Let me see the table. The last value is 7.3. Going up 09C6E. This is probably the size, because now this is relative offset, and then the next value starts here, relative. Missing 4 here, and the rest seems to be 5353. And this is just going up number identifier. What's the 53? Let's compare with the other one. So it starts here. Was about here, right? Compare her again. Oops. There we go. 4B01. Is that correct? 4B is here. Yes, 01 4B. Okay. And this will be the last file. And then some strange stuff happening. So 68 9696 15151C 73. Sorry, these could be sort of file types or something. Problem is where to begin, because this is clear. Start here, read this, and I know that org files usually start at org, so that means that this whole part here is additional information. This is not a size variable, probably. 6E76. Whoa. Seven six. Could be. Then 4 and then no more. This could still be padded or something, I don't know. Okay, so think that's a little bit more figuring out what's going on, because here it says 69C. That will probably be for the whole thing, right? So going there, 69C. Oops. 69C. That's here. 4 and then 12. Just excuse me. Just checking this. No. Two. $12. Okay. 12. This could be a maximum of then 2, and then E, and then something, and then something, and then the size. So do we have that? I mean, we don't have that for this particular file here, right? Where we going? Here. That starts here, somewhere here. What it said it was 6.8 in size. Okay, then another file starts here, but again, like B. Zero. Eight. Excuse me. Well, that says that's got a different size, right? And this is the table here. Sorry. BC size 2.8. Okay, so we could actually extract stuff here, but just going by the string to offset, that's going to be interesting, because 1850 is still a bit off. That's here. But that fits the 6.8, because the next one starts here, then BC. BC. Well, it's not correct, because the next one's BC is including the name. How's that? Yeah, it could be. Let me see. How's that for the other ones? Six is matching. BC is 2801. If it's starting here, let's just take a piece. What's that again? 128. Where am I? Here. Yeah. BC. It's okay. This seems to be working. So I think we can extract these files and later look at the difference. Because this you can use MultiEx also to just do some further analysis later on. So let's just start it up. This cold is just killing me. Run this. God damn it. Let's just get a script up and running. So this is AI war fleet command and analysis. So what we're gonna do, we're going to get header size. We're gonna get archive size. We're not gonna bother with them because we're not gonna bother with anything here, right? We can just skip all that. Okay, we can do this and then check this one, reverse it, and then jump to here to 84. That's 40. Where are we going? Here. Get dummy long 0. Get file number. No. What did I say? Data offset long 0. Set jump long 40. GoTo J 0. Get FileNum Long 0. This is not good. We need to ReverseLong DataOffset. Okay. And then we're all set. So for T0 to FileNum. Sorry. And then while we're there, we get the file ID long 0. We get what was it again? Let me just check this in one of the tables. Oh yes, the relative offset, the relative size, and the type. Type 1, Type 2, because I know there's difference excuse me, in this one. Just the final one though. This is a -1 and then 7.2. No, let's just forget about this one for a moment. So relative offset. Get size. Get type 1. Get type 2. Okay, now we're ready to log. We don't have a name yet. So set file name string T. So we're going to give it a number of T. String file name plus. So I add. Okay. We add now type 1. Add this one again. Add type 2. And then add dot binary. Okay, now we got a file that's given the number of T. We give it also type 1 and type 2, so we know when we're going to do an analysis of it, what type we're looking at. Okay. Log file name. We forget. Math. Relative offset. Add the data offset. Size. Next T. Okay then, that should be it. No errors, good. File, save it just for argument's sake. Put it, I don't care where. This is, no, we do care where. We need to go to GOG Games and then this fleet and this whatever it is, and then do it here somewhere as assets.txt. Enable the debugger, run it on. Like I said, warfleet command, wargame, war data, resource assets, go. Step by step. Okay, jump to 40, cutting the number of files. Looping, yes. File ID, relative offset size, type 1, type 2. Variable 14 was set to 1, that's a string. Adding different strings. Hey, that's interesting, what's going on there? Adding binary. Relative offset, go. Next. Run this for a while. Well, why are you not stopping? Because let's pause this. Okay, it's taking a while. Done, huh? Okay, but why are you not doing this particular one? Because it's written here that you should actually do this, huh? Maybe if you do this one, I don't know, this should be working. Save it. Excuse me. Yes. Anyway, I think we can extract a lot of these things. Let's just do a number of files, 10, extract this to whatever it is here. Give me a new folder called extracted. Go. Extracted. Excuse me. Alright. Ends here. What about the next? Yes. Probably extracting right. Short, tiny, rapid enemy. So there are file names in there, at least type names for the resource. I don't know why this is doing it. It should be doing it right. I'm gonna do another one. Use it on the shared assets. That works. just plain odd, right? Cancel, exit. Yes, I know it's an empty list file. I'll do it without the debugger. Run it. No, I'm just very curious. Yes. Use on. Huh. I'll be damned. I discovered a new bug in this parser. You gotta be kidding me, man. Okay, so let's say you always gotta find ways to go around that. Just for argument's sake, man. Now I'm gonna do this. You're not gonna care, that's right. Save. Use it on a file. Okay. That's a stupid workaround. But it works, so who cares? And let's extract some stuff here. Just extract them all. Thank you. Done properly. So now we got them, and we can take a closer look at them, right? So this is F1, so 53, right? Hexadecimal 5353. The last one in the row was -1. That's right. And 300 small bowls. All right, finish. Well, I mean, obviously the game has its own format to process certain files. Tutorial step assembly sharp.dll. Interesting, huh? What about this? Minor faction logic exodian blade. Minor faction logic exodian blade assembly C#. Interesting. Alright, so anyway, that seems to work. So with this script you can at least extract the resources and take a closer look at them. See, so this is just a way I show you how you can use this to get some files out and do some further analysis. Because this one, apparently the 4848 type, doesn't have this. This is interesting, huh? 2A5, this particular size. So this looks like a script, right? This is just pure text. You can just copy this into any text editor, and it's a shader script. Interesting. So thank you for watching. I think this is an example of how you can just use a script in MultiEx Commander to help you analyze some files or resources, and meanwhile extract them as well, and do your stuff with it. Okay, bye bye.